Okay, let's talk about number 3. Okay, we're gonna try to do the rationalized denominator. Okay, which means mathematician doesn't put the radical number on your denominator. Okay, so we're gonna try to make non-radical form on your denominator, which is rationalized denominator. Okay, to do so, we're gonna just it is simply okay. The first 3 problems are really simply just multiply the suitable power of your denominator. Okay, so for the first one, and we're gonna multiply, and that's enough. Do you know why? So okay, so let me explain this like this way. So look at your denominator. That is, as we learned about it, it is 2 to the 1 half, right? Then to make it non-radical form, then you have to multiply another 2 to the 1 half, then your exponent will be 2 to the 1. Does it make sense? Then you're not gonna have any radical on your denominator, okay? But keep that in mind, whenever you multiply something, you have to do the same thing on your numerator, okay? So it will be done like this way, okay? Then that is equal to square root of 2, and square root 2 times square root 2 is 2. That's it. This is the basic technique for the rationalized denominator, okay? So what about second problem? Oh, index is 3, but keep that in mind. This one means 7 to the 1/3, okay? To make it non-radical on your denominator, you need a 7 to the 2/3. Does it make sense? So we're gonna multiply. Let me write like this way, okay? Okay, look at denominator. 7 to the 1/3 times 7 to the 2/3, which is 7 to the 1. Is that clear? Okay, so this one is 7 to the 2/3 over 7 to the 1. So like with your numerator, we can write as the radical form, which is third root of 7 squared over 7. That is another skill for rationalized denominator, okay? Let me try to do the same thing for next problem, okay? Look at C, okay? Look at that. Your denominator has like a fourth root of the 5, which is 5 to the 1/4. Then as I explained, we need to multiply 5 to the 3/4. Then you can make your denominator as 5. Is that clear? So we're gonna multiply 5 to the 3/4 over 5 to the 3/4. Okay. Then what happened? Don't do anything for your numerator, okay? Because I will tell you why, okay? Your numerator is what? 5 times 5 to the 3/4, and denominator will be 5 to the 1. Is that clear? And then you can easily find this 5 will be canceled out. Like no matter we have to simplify, okay? So finally, it is equal to 5 3/4, or we can write as 4th root of 5 cubed. Is that okay? And what about the, wait a minute, there is different situation, okay? So your denominator is not only one single radical, but it is combined with like something plus or minus thing, right? Then you have to know the conjugate. The conjugate of this one is what? We're gonna multiply the conjugate of this one, okay? So what is that? Just put the negative sign for the your square root, okay? Or like you could just put the negative sign for your 6 as well, okay? It doesn't matter, okay? But basically the conjugate means we're going to change the sign of the square root, okay? So that one is equal to numerator. I'm not going to do anything, just write again. Then I will take care of this later, okay? And denominator is square root 2. Like when you do the distribution of this one, it is minus square plus 6 square, which is, let me write again, and we're going to take care of this one later, okay? Over negative 2 plus 36, which is, let me distribute your numerator. It is negative 7 square root of 2 and 42 over 34. So like there's nothing radical number on your denominator, okay? So again, like we could like this way, or we just simply multiply square root 2 minus 6 on top of bar, okay? But you know what? the result will be same, but like it will be opposite sign, okay? But like the top and bottom, both of them are opposite, okay? So like they are exactly the same, okay? What about E? Oh, it looks a little bit different, but nothing different, okay? So that big square root for your 3/8, like as I told you, it is power 1/2. And power 1/2 will work on your numerator and denominator separately, okay? So like this can be written by just simply like that way, right? Then to do the rationalized denominator, and we should multiply, then you are not going to have like any radical for your denominator, okay? That is the purpose, okay? Then, okay, that is square root, like look at numerator, square root of 3 times square root of 8, okay? Then you can combine like big square root, okay? Then you can multiply 3 and 8, okay? That is square root of like 24, okay? Over 8. Is it okay? But wait a minute, we can do a little bit more. What is that? So we know about 24. Okay, when you do the like, tree factoring, 24 has the two, let me do on the side, it should better. 24 has 2, 12, 2, 6, and 2, 3, right? Can you see one pair of 2? It is 2 square, right? That 2 square can be come out from the radical. Does it make sense? So this numerator 24 can be written by 2 square root of 6, right? 8. Then we can simplify a little bit more as much as you can, okay? That's it. This is the rationalized denominator with the simplest form, okay? And what about f? As I showed you this one, like on your denominator, not singular radical, but like there is something added or subtracted on your denominator, okay? Then as I told you, we're gonna multiply the conjugate of your denominator, okay? So you should better put the parentheses, a plus square root of 5, which is conjugate of your denominator, and don't forget you have to multiply the same thing on your denominator, okay? The numerator, don't forget this one. It must be 4m, which means you have to do the distribution, okay? Like that way. And denominator is okay? So that is equal to, let me take care of numerator first, okay? 8 times 8, 64. And when you combine these two, it is 16 square root of 5. And square root of 5 squared is 5, okay? Denominator is 64 minus 5, okay? Do you remember the difference of squares? Okay? Just like a simple distribution, but we can just memorize as the formula, okay? It's like this way, okay? It is equal to 64 plus 5 is 69 plus 16 square root of 5 over 59. That's it.